You cannot add another 30 amps double pole breaker to the subpanel. The subpanel is already at its capacity limit. The existing breakers draw the following amperage. The 60 amps double pole breaker draws 60 amps. The 1220 amp single pole breakers draw 240 amps. This is calculated by multiplying 12 by 20. The total amperage draw of the existing breakers is 300 amps. The subpanel's capacity is 125 amps. Therefore, the subpanel is already overloaded by 175 amps. This is calculated by subtracting 125 amps from 300 amps. Adding another 30 amps double pole breaker would further overload the panel. Therefore, it is necessary to upgrade the main panel to handle the additional load. The main panel's 125 amps breaker may also be insufficient to handle the increased load. You would need to install a larger breaker in the main panel to provide enough power to the subpanel. Here are the steps to take. Firstly, contact a qualified electrician to assess the situation and determine the appropriate upgrades. Secondly, upgrade the main panel to a higher amperage if necessary. Thirdly, add a new subpanel or enlarge the existing subpanel to accommodate the additional load. It's important to understand how electrical loads are calculated and how they relate to the capacity of your electrical panels. Overloading a panel can create significant safety hazards including overheating, fire, and equipment damage. The National Electrical Code, or NEC, provides guidelines for calculating loads and sizing conductors and overcurrent protection devices, such as breakers. Before adding any new circuits or equipment, it's crucial to perform a load calculation to determine if the existing panel has sufficient capacity. This calculation involves adding up the amperage of all the connected loads and comparing it to the panel's rating. When calculating the load, be sure to consider both continuous and non-continuous loads. Continuous loads are those that operate for 3 hours or more at a time, and they are required to be calculated at 125% of their rating. Non-continuous loads are those that operate for less than 3 hours at a time, and they are calculated at 100% of their rating. In your specific case, the subpanel is already significantly overloaded, indicating that the existing load exceeds the panel's capacity by a large margin. Adding another 30 amps breaker would only exacerbate this problem, increasing the risk of overheating and fire. Upgrading the main panel is essential to provide sufficient power to the subpanel and to accommodate the new load. The size of the main panel upgrade will depend on the total load of the subpanel, as well as any other loads that are connected to the main panel. It's also important to consider the size of the service entrance conductors, which are the wires that bring power from the utility to the main panel. These conductors must be large enough to carry the total load of the panel. If the service entrance conductors are not large enough, they will also need to be upgraded. When upgrading the main panel, it's important to choose a panel that is appropriately sized for the current and future load. It's also important to choose a panel that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or UL. This ensures that the panel meets safety standards and is suitable for its intended use. In addition to upgrading the main panel, it may also be necessary to add a new subpanel or enlarge the existing subpanel. This will depend on the number of circuits that are required to serve the new load. If the existing subpanel does not have enough available spaces for the new circuits, then a new subpanel will need to be added. Alternatively, the existing subpanel can be enlarged by adding more spaces. When adding a new subpanel, it's important to choose a location that is easily accessible and that provides adequate ventilation. It's also important to choose a location that is protected from moisture and other environmental hazards. The subpanel should be mounted securely to a wall or other structural support. All electrical work should be performed by a qualified electrician who is licensed and insured. The electrician will be able to assess the situation, determine the appropriate upgrades, and perform the work safely and in accordance with all applicable codes and regulations. Attempting to perform electrical work yourself can be dangerous and can result in serious injury or death. It's also important to obtain all necessary permits before starting any electrical work. Permits are required to ensure that the work is performed in accordance with local codes and regulations. The permit process typically involves submitting plans to the local building department and having the work inspected by a building inspector. Here is a more detailed explanation of the steps involved in upgrading the electrical system. Firstly, the electrician will perform a load calculation to determine the total load of the subpanel and the main panel. This calculation will take into account all of the existing loads, as well as the new load that will be added. Secondly, the electrician will determine the size of the main panel upgrade that is required. This will depend on the total load of the subpanel as well as any other loads that are connected to the main panel. Thirdly, the electrician will determine the size of the service entrance conductors that are required. These conductors must be large enough to carry the total load of the panel. Fourthly, the electrician will obtain all necessary permits from the local building department. Fifthly, the electrician will install the new main panel and service entrance conductors. Sixthly, the electrician will add a new subpanel or enlarge the existing subpanel if necessary. Seventhly, the electrician will connect the new circuits to the subpanel. Eighthly, the electrician will test the new system to ensure that it is working properly. Ninthly, the electrician will have the work inspected by a building inspector. It's important to note that the cost of upgrading the electrical system can vary depending on the scope of the work. The cost will depend on the size of the main panel upgrade, the size of the service entrance conductors, the number of new circuits that are added, and the labor rates of the electrician. It's always a good idea to get multiple bids from different electricians before starting any work. This will allow you to compare prices and to choose the electrician who is best suited for the job. When comparing bids, be sure to ask the electricians about their experience, their qualifications, and their insurance coverage. It's also important to ask for references from previous customers. In addition to upgrading the electrical system, it's also important to ensure that the electrical system is properly maintained. This includes regularly inspecting the electrical panels, breakers, and wiring for any signs of damage or wear. It also includes replacing any damaged or worn components. Regular maintenance can help to prevent electrical problems and to ensure the safety of the electrical system. Some common electrical problems include trip breakers, flickering lights, and sparking outlets. These problems can be caused by a variety of factors, including overloaded circuits, loose connections, and damaged wiring. If you experience any of these problems, it's important to contact a qualified electrician to investigate the cause and to make the necessary repairs. Overloaded circuits can be caused by plugging too many appliances into the same circuit. This can cause the breaker to trip, which is a safety mechanism that is designed to prevent overheating and fire. To prevent overloaded circuits, it's important to distribute the load evenly among the different circuits in the electrical system. Loose connections can be caused by vibration, corrosion, or improper installation. Loose connections can cause overheating, sparking, and even fire. To prevent loose connections, it's important to have the electrical system inspected regularly and to have any loose connections tightened. Damaged wiring can be caused by rodents, moisture, or physical damage. Damaged wiring can cause shocks, fires, and even electrocution. To prevent damaged wiring, it's important to protect the wiring from rodents, moisture, and physical damage. It's also important to have the electrical system inspected regularly and to have any damaged wiring replaced. In addition to these common electrical problems, there are also some more serious electrical hazards that you should be aware of. These hazards include electrical shock, electrocution, and electrical fires. Electrical shock can occur when you come into contact with a live electrical circuit. The severity of the shock will depend on the voltage of the circuit and the amount of current that flows through your body. Electrical shock can cause muscle contractions, burns, and even death. Electrocution can occur when a large amount of current flows through your body. Electrocution is almost always fatal. Electrical fires can be caused by overloaded circuits, loose connections, or damaged wiring. Electrical fires can spread quickly and can cause significant damage to property. To prevent electrical shock, electrocution, and electrical fires, it's important to follow these safety precautions. Never touch a live electrical circuit. Always use insulated tools when working with electricity. Wear rubber gloves and shoes when working with electricity. Never work with electricity in wet conditions. Turn off the power before working on any electrical equipment. Have the electrical system inspected regularly by a qualified electrician. By following these safety precautions, you can help to prevent electrical accidents and to ensure the safety of your home or business. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always take precautions to protect yourself and others from electrical hazards. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before making any changes to your electrical system. Failing to do so can result in serious injury or death. The NEC is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years to reflect the latest advances in technology and safety. The NEC is adopted by most states and local jurisdictions in the United States. It is important to be familiar with the NEC requirements when designing, installing, or maintaining electrical systems. The NEC covers a wide range of topics including wiring methods, overcurrent protection, grounding, and bonding. It also covers specific requirements for different types of occupancies, such as residential, commercial, and industrial. The NEC is a complex document, and it can be difficult to understand without proper training. It is recommended that you consult with a qualified electrician or electrical engineer if you have any questions about the NEC requirements. The NEC is an important tool for ensuring the safety of electrical systems. By following the NEC requirements, you can help to prevent electrical accidents and to protect people and property from harm.